How's it going? It's Mason Dozier here again with ISA 4220 Fall Semester 2020, and today we're going to be talking about databases. Alright, let's get right into it. So a database is actually a central location in which an assortment of data is stored, and it allows multiple users and applications to simultaneously access, view, or modify data within the database. All databases are actually managed by Database Management Software, or DBMS, and this database management software allows data, users, and programs to come together and interface with one another within the actual database itself. And without these database management systems or software, users wouldn't actually be able to read or understand the information that the database provides, so the database would actually essentially be useless. Databases offer organization of data, and they offer two key functions, which is data integrity and data redundancy. Data integrity means that the data is accurate for processing, and data redundancy means that the data is stored in multiple locations. Databases are actually a pretty important tool for organizations because the info that they use must be accurate and backups must exist to ensure that that organization runs as efficiently and effectively as possible while keeping the data protected. For instance, if their information is incorrect, the organization risks losing customers, and even at some extremes for certain organizations, they may even face legal action, which makes the accuracy and integrity of data and the databases an essential area for all businesses. And if data redundancy doesn't exist, anytime a database is compromised or destroyed, all the data within that database will be lost, which can have a detrimental effect on any organization, which once again could possibly even lead that organization to being permanently shut down. Another key function of a database is access control and data manipulation. So using access controls helps protect the database and its data by allowing only those who are authorized users to access the data within that database. One of the big things with access controls is the principle of least privilege, which is a common technique, which basically just allows users to access only the necessary data which is required for those users to carry out their assigned tasks or duties. And then data manipulation operations allow users to sort and arrange data so that it can be interpreted in useful ways. These key functions of the database can cost a lot of money to organizations if there's any problems with that. And so it's pretty essential for organizations' best interest to protect database and their data with the utmost care. This is important for especially the employees of an organization who are charged with the administration of those databases, because if anything happens with those databases, those people might end up losing their jobs. So once again, the people who are in charge of databases and the organizations who use them should take as much possible time and effort to protect the databases and the data within them. All right, now that we know what a database is and some of the key uses of a database, let's talk about a little bit more of the technical side to it. So there's several different types of databases. There's a relational databases, hierarchical databases, network databases, object-oriented databases, and object-relational databases. So a relational database is by far the most common type of database used, and it uses columns and rows to present data in a table format. Hierarchical databases were actually one of the first database models used, and what it does is it uses a logical tree structure to format the data within the database. Network databases format their data using multiple parent-child records. And then an object-oriented database is actually a dynamic database that allows for data of like big data such as videos, pictures, and audio files to be stored within it. And then the last type is the object-relational database, which is actually a mixture of the relational and object-oriented databases. It's basically a relational database that's fronted by software that is written using object-oriented programming languages. All right, and as well as having different types of databases, there are also different programming interfaces for databases. The first would be an Open Database Connectivity, or ODBC. And this actually allows for local or remote access to an API, which allows for remote communications between an application and a database. Object linking and embedding databases actually use or have a data components that are separated and ran as middleware on either the client side or the server side, and provide access to low-level interfacing across various databases. ActiveX data objects is actually an API that allows back-end access for applications. And then the Java Database Connectivity, or JDBC, is an API that allows for communication between a Java application and an actual database. All right, let's talk about some, major uses of the actual databases and what the organizations would most likely use them for, especially in today's business world. The first would be data warehousing. This is actually a big function that a lot of organizations use. And what this is basically just when massive amounts of dynamic data, so different types of data, is pooled together so it can be analyzed and used to produce business intelligence. So basically they just pull a whole bunch of different information together and then analyze it to draw information out of that and use that information to help the organizations either provide a competitive advantage or to just get some sort of intelligence that they can use for their operation. And data mining is actually that analysis process that I just talked about, and it's used on large databases in order to create useful information from the actual data in the databases for businesses. This information is created from this process is actually called metadata. And metadata is technically just data about data. But what this is used for by organizations is it shows new relationships and patterns amongst all the data. And it's useful to organizations because it just helps them once again, provide more information from the data that they have and use it for their operation. All right, moving right along, let's talk about PostgreSQL, which is actually the databases we're going to be using in our server setups. PostgreSQL is an open source object relational database that's available from multiple OSs, including Linux, Unix, Mac OS, Windows, and a bunch of others. And this database actually provides reliability, integrity, and correctness, which are features that have led to its, why it's so popular. Postgres actually supports several different data types, including integer, numeric, boolean, date, interval, varchar, char, all kinds of others as well. And it's capable of storing all kinds of different data, such as large pictures, videos, and audio files, which are dynamic data sources. And its features in standard compliant, which is actually beneficial for organizations and auditors, especially in financial corporations who are subject to more intense auditing than most other organizations. So it has some definite uses for a lot of different organizations. All right, now that we know what PostgreSQL is, let's talk a little bit about more the technical side of it. It is compatible with multiple programming languages, including C, C++, Java, .NET, Perl, Python, Ruby, TCL, and ODBC. So there's a lot of different ways that it can be used, and it's compatible with a lot of different types of languages and data types of data. And let's talk a little bit about some of the limitations of Postgres. So the max database size is actually unlimited, and then the max table size is 32 terabytes, which is fairly large. Max row size 1.6 terabytes. Max field size or column size is 1 gigabyte. The maximum number of rows per table is unlimited. Maximum number of columns per table is upwards of about 1600. And then maximum index per table is unlimited. So, this can be a huge database if necessary, which is why I think one of the main reasons that it's, very useful to organizations, and another one of the reasons why it's so popular. All right, let's talk about some hardening recommendations for PostgreSQL. The first one, always, and first and foremost, let's always just go ahead and get this out of the way. I didn't even write it down in here, but keeping up to date is always important. I think that's just kind of a basic one, which is why I didn't write it down, and something you should do for any operating system or application or service that you're using on any computer whatsoever. The second, or I guess the first hardening recommendation that I put on here is create user roles. And so that just means, creating the regular users versus the super users, and defining those relationships and, capabilities for each of the users that are going to be accessing this database. Another tip would be to remove the public schematics and also use the AAA model, which is authentication, authorization, and auditing. This is important to just keeping the data within the database protected and accurate for use by an organization. Another good tip, which I actually didn't even write down in here, is to use virtual private desktops if that's possible for your organization or how you're going to be using it, because it helps to limit direct exposure to the database, which can just limit errors or any kind of exposure which could be damaging to the database. Using parameterized queries is another tip, which just helps prevent against SQL attacks. Encrypting the database is always important as well. That just keeps the data within the database itself protected against attacks or anybody that tries to gain access to it without authorization, or happens to somehow gain unauthorized access. Then that database is still encrypted and the data can stay protected. And then the last tip, which is actually probably one of the most important tips, would be using data masking. And what this is, it's just placing authenticated data in the database that kind of leads attackers away from the actual important data that an organization is trying to protect. And it's similar to a honeypot in that it just kind of like attracts an attacker's attention and isn't actually useful information, and it helps keep the good information that the organization wants to keep protected out of the line of sight of an attacker. And that about wraps up my presentation on databases in PostgreSQL. I hope you guys enjoyed listening to the presentation and found some useful information, and I will see you guys next week.